Right, this is Tales of Meadow. In the very late stages of production, we're basically just missing torch models and that's it. Everything else is here and ready to go. I'd just like to take some time to go over the coding of the game and how everything was put together. So we'll start with some graphics. So here we have two examples of some models, the dagger by Taylor McNally and the mace by Josh Massey. Very good models, they look very nice in game, that's why I decided to showcase these two. We'll just go on to looking at how they actually come into the Unreal Engine and how we get them to look all shiny and nice. So this is a wood texture for the walls, well, a wood material, and we basically make this by starting with a texture object of just the wall texture that we've made, and we sample it to get all the different outputs. And this is one example of when you only have one texture and you have to make the rest of the material based off of that. So you have all of these variables in your material and you basically have to make them all correct for the material that you're trying to make. So here this wood texture is not going to be very metallic because it's wood, so you take the metallic right down by multiplying by 0.1, say. So it's not very metallic because the metallic value is very small. And you can also, in some cases, use your texture as a height map if the material basically has a texture that's like, it's coloured to the indents, like this wood here. So each dark spot would be an indent and each bright spot would be an outdent. Similarly, here we have the roughness. The roughness of wood would be fairly high, so we times it by 2 to make sure it's high enough, make sure it's not very shiny, just to make sure it looks right, basically. And here we have another example of a material where we don't have, well, we do have, sorry, all of the textures that we need. So here we have a texture, a metallic map, a specular map, a roughness map, and a height map. So this makes it very easy for the coder's job because they basically have all they need. There's just minor tweaks here and there, like this multiplied by 1.2, it maybe needed a bit more, and divide by 4 on the roughness, maybe it was a bit too rough, just to make it shine a bit more and get the finished product here. Now I'll talk about some of the particle effects that we can see in game, like these torches. So Unreal has its own particle editor, and it seems very complex, but I'll try to put it in perspective. So here we have the orb that the player shoots. It's basically just a texture that I've generated. I'll show that here. Here it is. So I've generated it using a color input data from the particle effect itself, and I've made it a circle basically. That's all that's being shown here, and it's going into emissive color, showing that it's emitting the color instead of just being an object that's being lit. So here, hold on. So back here we can see that that's what that material looks like. It looks like it's emitting light and it's got the circle fade out. So the color is determined by this here, and it's constant, so it's one value over the whole lifetime. and it's just that value, and then the lifetime is 0 to make sure it never despawns. Its size doesn't change, so it just has a constant start size, which is 100 by 100 by 100. And particles are basically pictures, right? So they're sprites that are always pointed towards the player, and they're just told to move in certain directions, they're told to change color, they're told all of these different things, and you can have animated ones, like this explosion here. There are multiple things going on here, but basically we have a shockwave like that. That's just an animated sprite, an animated like picture of an explosion going out, and we've changed its color over life, so it goes from a very bright purple to a dark bluey purple, to make it look like it's expending its energy. We've also got some sparks that fly off just to make it look a bit nicer. We have the light here, which just makes it show in the middle, because otherwise it'd look like the orb that you just shot disappears immediately, and that wouldn't look too good. So we have a little fade out of that orb. So next we'll be moving on to physics. So the player in the game can move all of the objects with their orb shooting powers, and for example we're going to be looking at this candlestick, how it stays like this and then gets separated once you shoot it. So here we go. So here we have the candlestick. It's on its side because that's just how it is. So we have the candle holder here. Right. So we have simulate physics on because it's gonna simulate physics. However, we don't want it to start awake because then it would probably do something bad to the candle itself. It would probably just bug out and the candle would fly off, and so would the candle holder, and it wouldn't be what we wanted. So if we make it start asleep, then it'll be frozen until it gets an input from a force, or like the orb basically. And the same is here with the actual candle. It's starting asleep so that it doesn't collide with the candle holder itself, just basically to make sure it can stand up properly. These two obviously have different mass to make sure that it feels more realistic when you're shooting something. If you're shooting a coin and it goes less far than when you're shooting a barrel, it's not going to really feel that good because a coin should be lighter than a barrel. So you have the mass here, and the candle holder is lighter than the candle, not by much, but still by enough. And then if we go over to this barrel here, you can see that the barrel is heavier than both the other two. Right, now we will talk about the sound that the player can hear. So this is an interesting one. The sound is actually coming from this point all the way over here out of the map. There's a reason for this. It's meant to be inside the tavern that's out the room, so it would be realistically coming from here. And we had to fiddle with the attenuation settings to make it sound right. So here I'll show. Here's the object that is the sound. Here it has an audio component, and we adjusted the volume so that it's the right volume for the environment, and then we just adjusted the attenuation settings, so making it fall off quite far out so you can hear it in the room, but the inner radius is where you can hear it at full volume, and that has to be small so that you can't always hear it at full volume because it's not in the same room as you. Right, so now we'll be going on to the actual code that runs the game. Here is the character. So here we've got the player, capsule component, which is to simulate collisions so the player can't walk through walls. We've got the camera to show the player's viewpoint. We've got a sphere to set the location for spawning the orbs when the player shoots, so that's attached to the hand, and then we've got the mesh itself, which is visual representation of the character. So I'll go into the event graph, which is where all the code happens. We've got a lot of code here, but we'll start with the basics. We've got basic movement right here, or here, which is just, you know, you get a turn input and then you turn. It's very simple. It's just making sure that the player actually moves. Here it's a little bit more in depth because the player has to move forward relative to where they're facing and relative to where their 90-degree offset is. So now we'll move on to the HUD, which is the heads-up display, where the player gets all their information from. So we have two HUDs that we use. We use this one, which is it's the crosshair, basically. It just says put the crosshair in the middle, make sure it's in the middle properly, and that's about it for that one. But here we have the actual player HUD that tells everything to the player. So we have a health bar, which is bound to the player's health variable in here. So there's this health here, and this is changed by this little bit of code that says if the player takes damage, then they lose health. If the player hasn't been damaged in 3 seconds here, then they start healing. And the health regeneration rate is 0.00005 per second, which obviously you put it up to percentage, that's times 100. So we also have the mana bar, which is bound to the character's energy, which is set down here. The energy regenerates at 15% per second, and it doesn't have a delay on it because, you know, you use it and it starts charging instantly back, just to make sure the player can keep on with their shooting. Then we've got some prompts for opening doors, equipping the ring, and making sure the player can't exit when they don't have the ring. This is done up here. So we basically trace a line in front of the player. We make sure that line's not too long so they can't open a door from half the room away. So we basically say this line starts and ends in a certain vector, which we calculate down here. And we say, so that should be a certain length, which at the moment is 150 units. So there's 150 units line in front of the player from their central camera point, and that's always on, and it's always checking, and whenever it hits a door or the ring, it basically says that the ring is in range or the door is in range, which tells this HUD to show these messages. This, you should get your arcane ring first, is a little more complicated. It involves the actual fake door itself, because it's not a normal door, it doesn't open normally. So this basically says whenever you get the door function, so if the players press D on the door, make sure that they've got the ring. If they do have the ring, then you quit the game. If they don't have the ring, then don't do anything, because that's handled by the player itself. Over here. So down here we've got has ring exit, which basically says have they tried to exit and do they have the ring, and that's to make sure. So that shows this, right? So it's just a variable name, and it shows make sure you have your arcane ring. If they do have the ring, then it just sets the command so that they can exit the game. Next we have equipping the actual ring. So this is input action interact. This is the E button. Whenever the player presses the E button, they trace a line 150 units in front of them, like the one we've done up here, to show the in-range stuff. So it traces a line, then if the ring is on that line, then equip the ring, basically attached to the component at the ring socket, which is, so on this mesh we have a socket called ring, which tells the ring to go on the finger. Then you destroy the hitbox for the ring so that it doesn't get in the way of the orbs or get in the way of any door traces, so it doesn't stop you from opening doors. Then you tell the ring that it's been equipped so it can stop the particle effects that go on here, these little sparks. And then we've got opening doors, which basically just tells the door to open, and the rest of the code is done in the door itself, which says if the door is already moving, then don't try to move it whilst it's already moving, and then it decides which side, which way the door is it open or closed, and then it plays this timeline, which is just 0 to 1. You times it by 90, and that's how many degrees it moves, and you just negative that if you're going the other way. So play from start or reverse from end, just to open or close. So that's that part covered. Now we've got the actual spawning of projectiles. So you click to shoot, then it checks a bunch of things. It checks if you have enough mana to shoot, then it checks if you got the ring, and then it checks if you're not already in the middle of shooting. So that's these 3 checks here. Then once it's got the command to go through, it'll say, okay, I'll set your energy, set your mana minus the cost. So it takes off the mana, then it plays the animation to shoot. It has a delay before you can shoot again. It has a delay before the projectile comes out to let the animation reel up, and then it spawns the projectile, which is here. So this is made up primarily of particle effects. as I showed before. So you've got the sparks and you've got the orb, but you've also got other things. So the sphere here, the collision component here, is what collides with the world, and what generates the hits on physics objects and non-physics objects like walls. Then you've got the projectile movement and the light. So the projectile movement, it tells the projectile to move. So when it's spawned, it'll move in the direction that it's spawned in at 3,000 units per second. And it's basically all the physics is handled for the projectile in this projectile. Then we've got some coding here to say, so this section is saying if there's physics objects or a character in range, it will move them. So this add impulse is adding force, and this launch character is adding force to the character. So it's basically looking for anything within I think it's a 300 unit area, 300 unit radius. It looks for a player or any physics object, and then it adds impulse away from the explosion. Then you've got saying when you hit something, you stop and you destroy yourself, so that it doesn't keep bouncing around. That'd be chaos. So there's a bit of a delay before it fully fades out, so that the explosion can play and the light can fade out. That's basically what this is doing, this timeline here. This is saying despawn the component that's the actual orb itself. So this here, this orb, get rid of it and start playing the explosion. When the explosion is done, you set the intensity of the light lower so it fades out with this timeline, and then you destroy yourself to stop the game getting cluttered with invisible objects and things like that. So that's basically it. We've got playing sounds, of course, like the explosion sound over here. You've got playing the explosion sound, and you've got playing the fire sound, and camera shake, which is just a small shake in the camera when the player shoots. But that's it for the projectile shooting. It's all vectors, where to aim it and all that. So here we've got some code for a lightning line attack that I made, and it works, but it just doesn't look like I wanted it to. So I'll show it here. So this should connect up to here, and then if we set the zapping to false, it should allow us to use the lightning attack in game. So there it is. It's quite loud, but the reason we didn't add this in is because we couldn't get a light on the lightning bolt itself, so it wouldn't make a flash. It just kind of looks off, like, and it's way too overtuned. The physics impulse is far too high, but it basically didn't look how we wanted it to, and there was no real way to make it look like that, so we gave up on the attack. But it's still there in the code if we can ever make it any better. So it's fairly easy to disable. Right, so that's pretty much it for the player code. I don't think I really missed anything too important out. Basically, that's really it. The game isn't too complex, to be honest. It's just been difficult to learn everything, but now we've got everything down. We know what we're doing. We can pump out quality assets. So we've fulfilled our task. Thank you for watching.